Hello friends, hello scholars, and welcome to Edomat Hub. In this video, we're looking at the JAMB 2025 chemistry mock questions that came out in yesterday's examination. So stick with me to the end of the video because you stand to gain a lot. Let's go. The first question is, what is the component of water gas? What is the component of water gas? Now, the first thing to note is that water gas is one of the synthesis gases, which is used as a source of heat in many industrial processes. Now, note that water gas is composed of CO, which is carbon dioxide, plus H2. This is water gas. But there's another gas that looks exactly like this, but that gas is called producer gas. That one is CO plus N2. So CO plus N2 is called producer gas, while CO plus H2 is called water gas. So our major concern in this question is water gas. So the correct answer is option B. Okay, now let's move to the next one. For the next one, I told that an aqueous solution of glucose will A. Boil at a higher temperature than pure water, boil at a lower temperature than pure water, have the same boiling point as pure water. Now what they're asking here is that, you know that glucose is a solid, right? It's in solid form, but right now it is in aqueous form. That means it has been added to water. So what you have right here is G, which is glucose, plus H2O, water. So this is the solute and this is the solvent. So when you have a solute dissolving a solvent, the boiling point will be higher. This is under what is called colligative property, which is a physical property of a solution that depends on the number of solute particles present in it. Okay, so that solution depends on the amount of glucose that is present. So this will raise the boiling point of that solution. So the boiling point of aqueous solution of glucose is higher than the boiling point of water because of the presence of glucose there. Okay, which is like the impurity. So the correct answer is option A. So it will boil at a higher temperature than pure water. So the correct answer is option A. Now let's move to the next one. Coordinate bonding occurs in dash. Okay, coordinate bonding occurs in dash. Now, coordinate bonding is a kind of bond that occurs when an atom donates a lone pair of electrons, okay, to form a bond. So this kind of bonding will occur when you have a particular atom donating a lone pair. A lone pair just means that a set of electrons that is not used in bonding. Let me give you an example. Let's look at what you have in ammonia, for example. Now, ammonia is NH3, right? Ammonia is NH3. If you look at ammonia, this is nitrogen here. Nitrogen is atomic number 7, right? If you do the configuration, you're going to get 1s2, 2s2, 2p3. So the total here, the total of everything here is 7, right? Now, this nitrogen here wants to bond with 3 atoms of hydrogen. So it will look like this. This is the last outermost shell that you have. Okay, this is 2, 2. So this is outermost shell. So nitrogen has 5 electrons, 2 plus 3 in its outermost shell. So that will look something like this. This is nitrogen here. So it will have 5 electrons. 1. Let me put 2 here. Let me put on that 2 here. So that's 5 electrons. Now it wants to bond with 3 atoms of hydrogen. So this is hydrogen coming. This one hydrogen. This one hydrogen. This one hydrogen. So when they bond, they will take 2 electrons each. Like this 2 will bond. This 2 will bond. While these 2 will bond. So you notice that there will be 2 electrons left. These 2 electrons will be unpaired. Will not be used in bonding. These 2 here. So they are called lone pairs because they are not used at all. So at the end of the day, to look something like this when you draw the diagram, to look like this. So you have N here, you have 2 electrons here that are not used at all. These are the 2 electrons that are not used. Then you have 2 electrons here for 1H, 2 electrons for 1H, then another 2 electrons for another H. So this is ammonia molecule. Now when this ammonia molecule combines with an H+, H+ is what is called proton. It does not have any electron. You can see it's just plus. Now for this to happen, these 2 electrons here, we have to combine with this H+ here. Nitrogen will transfer the lone pair that was not used in bonding to the H+. At the end of the day, to now form what is called the ammonium ion, which is NH4+. So the bonding in ammonium ion is called a coordinate bonding, or you can call it a dative covalent bonding. So it occurs when you have an atom donating a lone pair. You can see these 2 electrons went to meet H+, which is the proton. So that answer to that question is A. Occurs in atoms with lone pair of electrons, as you can see in what we had in nitrogen just now. So for the next one, which of the following absorbs water from the atmosphere to become dilute? Okay, so which ones will absorb water from the atmosphere and like they will become dilute or they form a solution? So the correct answer to that question is deliquescence, okay, or deliquescent substances like what you have in sodium hydroxide. So this one here, hygroscopic, are substances that they absorb water but they do not dissolve in the solution. Okay, they just absorb the moisture. So the correct answer here is deliquescence. So that's option B. Which of the following is used in miner's lamp? Miner's lamp is a kind of lamp that was used in the olden days. Even up to now, it's still being used by explorers in caves and so on. So that lamp uses a gas. The name of that gas is called acetylene. Acetylene. And acetylene can also be called ethine. So the formula of ethine is C2H2. Okay, so the correct answer to that question is option A. Next question, we are told that H2 plus Cl2 in a reversible reaction produces 2HCl, okay, which is hydrogen chloride gas. What is done in order to increase the rate of reaction? Okay, so this is under chemical equilibrium. It's forming the experiment in a dimly lit room, okay, by cooling the system, by removing HCl as soon as it is produced, by increasing the volume. So for you to solve this question, you need to first of all understand the Chandler's principle, which is just a basic idea telling you that whenever you introduce a change to a system, the system will produce its own change to counteract the change that you have produced. Now, by performing the experiment in a dimly lit room, this experiment will not take place because chlorine is a halogen, and most halogens are active when there is bright sunlight, okay, or when the environment is bright. So this one is wrong. By cooling the system, if you cool this system, this reaction will not move in the forward direction because you're trying to increase the rate of reaction. You're trying to increase the production of HCl. So you need to increase the temperature, not to cool it. Then the next one is by removing HCl as soon as it is produced. This is correct because in the Chandler's principle, as you are removing the products, the system will be try to increase the production of the products. Since you are removing it, the system will try to increase the production of the products, so the reaction will proceed in the forward direction. Okay, so this one is legit. Then the next one is increasing the volume. Increasing the volume for this reaction will not favor the forward direction, because if this reaction is taking place in a very small container in which Cl2 and H2 particles are colliding at the faster rate, if you now increase the volume, you make it bigger, they will not collide very fast because the distance between them will be very, very far apart. So for Cl2 to collide with H2, it has to travel a very far distance. So the forward reaction will not be favored. Meanwhile, it's going to favor the backward reaction. The forward reaction will not take place at a very faster rate. So this one is wrong. So the correct answer is option C, by removing HCl as soon as it is produced. Next one. Which of these has a characteristic sweet smell and is gotten by the action of cold water on calcium carbide? Now, first of all, you need to first of all know what's calcium carbide. Calcium carbide is CaC2. That's the formula of calcium carbide. Now, they said action of cold water, as you can see from here. So that means you are reacting this with water. So if you react this with water, you're going to get, this is water and this is calcium here. So you're going to have what's called calcium hydroxide first. So that will give you CaOH bracket 2. Then this will now produce a gas. That's C2H2. C2H2 is acetylene or ethine. So ethine is produced. And ethine has a sweet smell. Not really sweet like that, but a sweet, pungent smell. So don't be confused about the options. Just look for ethine there and pick it. So this is ethine here. You might be confused to go and pick this one as the answer. This is wrong. This is an ester. Esters have sweet smells, yes, but they're not produced by the action of calcium carbide on cold water. Okay, so this is a tempting option, but it is not the answer. Okay, the answer is C2H2, which is ethine. The answer is option B. For number 8, we are given C2H5OH plus CH3COOH produces this plus water. Now, C2H5OH is called ethanol. This is acetic acid or vinegar. And this is ethyl ethanoate. Right, this one is water. So we are told that what is this process called? This is a very common process in organic chemistry. This process is called esterification. Okay, esterification. Okay, when you combine um, alkanol, when you combine alkanol plus carboxylic acid, it will give you ester plus water. So, but the reverse process, when you reverse it, okay, when you reverse it like this, you're going to call it, you're going from, you're adding water now to the ester. Since you're adding water to it, that will be hydrolysis. And this reaction which takes place in presence of an acid. So this backward reaction will be called acid hydrolysis of ester. So it is not vulcanization, it is not dehydration, it is not esterification. Esterification is a forward reaction. Okay, it is not any of these guys. So the correct answer is option B, which is the acid hydrolysis of ester. So this is the ester here, right here. So when you add water to it, in the presence of an acid, it will give you two things, ethanol and a carboxylic acid, which is ethanoic acid. So the answer is option B. Okay. So moving on to number 9, we have this equation right here. So we are told that in the above reaction, ammonia acts as a what? So for this question, there are no options because we're unable to get the options for this particular question. Now, what they're asking you actually is they are trying to ask you, is ammonia acting as a reducing agent or is acting as an oxidizing agent? It's a very simple question. The easiest way to get this question is first of all, spot ammonia on the left hand side. Then look at what it became on the right hand side. So you notice that copper oxide here, which is copper 2 oxide, it became ordinary copper. That means the oxygen in it, this oxygen in it was removed. So ammonia removed the oxygen that was in copper and it turned the copper 2 oxide to ordinary copper. While the ammonia took the oxygen to itself and it became this guy here. So that means ammonia is acting as a reducing agent because it is removing the oxygen from copper 2 oxide. It removed the oxygen here and put it on itself. So ammonia is acting as a reducing agent in this question. So the answer is ammonia is a reducing agent. For this next one, we have 3Fe plus 4H2O produces Fe3O4 plus 4H2. The reaction above, the reducing agent is what? So to find the reducing agent. So to find that easily, just look at the one that took the oxygen. So from here, Fe was alone here, but Fe had oxygen here. So Fe was oxidized. So that means Fe is the reducing agent. Okay. Why this H2O that was here? It gave its oxygen to Fe. You can see oxygen. You can see Fe took the oxygen. Why the H2O became ordinary H2. So H2O there is the oxidizing agent. Why Fe is the reducing agent. So the reaction above, Fe is the reducing agent. So Fe is the reducing agent. Just put it like that. Next one, an organic compound that can undergo addition reaction is dash. First of all, you need to notice something. Addition reactions are undergone by compounds that have double bonds or triple bonds, not compounds that have single bonds. Okay, so just look at the ones that have double bonds there, or the ones that have single bonds. This is butanamine. Butanamine has single bonds all through. This is butane. Even if you look at the name, it's sounding like normal alkanes. They are sounding like normal alkanes. Butanamide, butane, butanol, they are all like single bonds. It's only butene that has double bond because it's an alkane. So these guys are not the answer. The correct answer is butene. Butene undergoes addition reaction. So for the next one, sulfur 4 oxide can be used as a, so you have coating agent, generating agent, refrigerant, drying agent. Answer to this question is very easy, which is SO2 is always used as a reducing agent most of the time. So reducing agent, it bleaches by reducing or by reduction, but it is a dehydrating agent because when it combines with water, it will form an acid called H2SO3 or sulfurous acid. SO2 can be used as a dehydrating agent because H2SO3 is an acid, and the acid H2SO3 even H2O4 are always used as deaeration agents, okay, to remove water content or water moisture from different organic compounds or from compounds. Okay, so the answer is B. Now for the next one, we have this one here, CH3CHO plus NaBH4 under an acidic medium. You can see H plus there, produce a compound X. So you are told that the product X above is what? What is the product X above? What is X? That's what they are trying to ask us here. The first thing to note is this compound here, which is NaHBH4. This compound is a very strong reducing agent, and it has a name. It is called sodium borohydride, or you can call it sodium tetrahydroborate 3. Okay, it's a very strong reducing agent, and it can be used to reduce different compounds. Now, this compound here is called ethanol. You can see the functional group CHO. The functional group CHO are for alkanals. Alkanals. So when you reduce alkanals, you're going to get what is called alcohols. So this is ethanol here. CH3CHO is ethanol. So when it undergoes acidic reduction, you can see H plus here to tell you that the medium is an acidic medium. Using sodium borohydride, it will produce a compound X. So since this is ethanol, then this one will be ethanol. If this is methanol, then this one will be methanol. So that's the idea, that's the scope to use. So since this is ethanol, this will give you ethanol. So the formula of ethanol is C2H5OH or CH3CH2OH. So the correct answer to this question is option C. This option C here is ethanol. CH3CH2OH. That's the formula of ethanol. Okay. Just to add something to this question, that's to tell you that if you reverse this reaction, that's if you oxidize your alcohol, you're going to get what is called alkanal. Okay, so just keep that in mind in case JAMB changes the question for you in the main JAMB exam on 25. So the next one, the quantity of electricity consumed when 10 amperes was passed through 1 hour in electrolysis is dash. This question, there were no options. We were unable to get the options. So to solve this question, just use the formula Q is equals to IT. That's the formula for quantity of electricity, and the unit is coulombs. So just check the current in the question. Current is 10 ampere, so that will be 10 times the time. You need to put this time in terms of seconds. So 1 hour is 3,600 seconds. So let's multiply these two. This will give you 36. This will give you 36,000 coulombs. Okay, so that's the answer to that one. Take note of that. An element undergoes oxidation when so you have option A, which is oxidation number decreases, oxidation number increases if it's a reducing agent and if it's an oxidizing agent. Basically, oxidation is increasing oxidation number. When the oxidation number of an element increases, maybe from 0, it increases to maybe 2 plus, then you say the element has been oxidized, or you say that compound has been oxidized. So basically, oxidation is increasing oxidation number. So the correct answer to that question is option B. So option B is the answer. Then for number 16, we have an aqueous solution of an oxide which changes blue litmus to red is dash. Now, when blue litmus paper changes to red, that signifies acidic character or acidic property. Okay, telling you that thing has an acid in it. So the simple answer to that question is acidic. Okay. And for number 17, a chemical change will be spontaneous when dash. You first of all need to understand what a spontaneous reaction is. This is basically a reaction that really doesn't need too much external factors to make it start. So basically, for spontaneous energy, you need to understand what is called free energy. So free energy is given by delta G is equals to delta H minus T delta S. So anytime free energy is less than 0, then the reaction will be considered to be spontaneous. And that will happen maybe when delta H is negative and when this delta T delta S is positive. Okay, so keep that in your mind. Spontaneous reactions are reactions that have free energy less than 0. That is delta G is less than 0. So the answer to that question is the free energy change is less than 0, which is option D. So we'll move to number 18. If you are still watching, thank you for supporting Edumat Hub, and don't forget to click the subscribe button. Okay, don't forget. Let's go. Now the next one is butene is an isomer of what? So the first thing to do is to get the carbon chain. So since you have but here, but means 4 in organic chemistry. So you're going to draw 4 carbon chains first. So you have 4 carbon chains. Then, and since you have 2 here, that means the position of the double bond is in the middle, not at the end here, but in the middle. So put it in this center here. So each carbon atom can only have 4 lines around it. So this one already has 3 lines around it. So just add 1 to it, put 1 here. This one already has 3 lines, add 1 around it, put 1 here. This one has only 1 single line. So just add 3 around it. Okay, then put 1 here. Then this one too, like that. So if you check this structure very well, you must have 4 carbon atoms. You already have 4 carbon atoms already. Then this molecular formula will be C4. Okay, then these guys here are the hydrogen atoms. I don't want to write them out, so it will not waste too much time. So just count those lines. How many of them do you have there? So you have 1, 2, 3, 4, 5, 6, 7, 8. So C4H8. That's the molecular formula. C4H8. So this is an alkene. This is butene. Next thing to do is just to check the other options. Pentene means 5 carbon atoms. So this is C5, then H whatever. It cannot be the same as this one. They don't have the same molecular formula. This one is C5, this one is C4. So that means option C cannot be the answer. So eliminate option C. This one cannot be the answer. The same thing with X2N. X2N means C6. C6 is not the same as C4. So that one too cannot be the answer. So this one is striked out. So our answer is just in between these two guys. To get your answer faster, propane means 3, right? Propane is 3 carbon atoms. That's C3, 3 carbon atoms. But you have a methyl here. That methyl will now make it 4. Methyl is CH3. So at the end of the day, you have 4 carbon atoms in total. C3 plus C1, which will give you C4. That's for option A. But if you look at option B, which is 2-methyl butene. Butene here, butene is 4. You now have 2-methyl. You have a methyl and you have butene. So butene is C4. And you now have methyl there. That methyl now is C1 or ordinary C. That will be C5. C5 cannot be the same as this formula here. So you can see that these options are out of it. Option B is out of it. Option C is out of it. The only answer there is A, because A will give you 4 carbon atoms. Propane, which is 3, plus methyl, which is 1. So at the end of the day, you have C4H8. So the faster way to get the answer is this method I just gave to you. So the answer is option A. Okay, option A is the answer. The next one, a hydrocarbon with vapor density of 21 has 36 grams of carbon in 1 mole. What homologous series does it belong to? The first thing to do is to signify the hydrocarbon. Just write CXHY. So you are told that the vapor density is 21. So vapor density and molecular mass are related because vapor density times 2 will give you the molecular mass, as you can see from the formula on your screen right now. So to get the molecular mass, which is Mr, just times this guy by 2. So that will be 42. Then come back to this place here and just write the relative molecular mass of carbon is 12. So you just write 12x, okay, plus hydrogen is 1. Just write y is equals to 42. This is what you must get. Okay, but from the question, you can see that the carbon there is 36 grams. That means everything from here like this must give you 36. So you just equate 12x equals to 36. From there, solve it. You're going to get x is equals to 3. That means in our hydrocarbon CSHY, the value of x is 3. This guy here is 3. So we're going to have C3. That's the first thing. Now to get HY is very, very simple. Since you have already seen that everything is 36 grams for the carbon, then what will be for the hydrogen? Just do 42 minus 36. So 42 minus 36. Everything I'm going to get here is 6. That means the hydrogen there is 6 grams. So at the end of the day, you're going to have C3H6. That means the value of Y is 6. So C3H6. C3H6 is an alkene because alkenes follow the formula CnH2n. Okay, so this answer is alkene. Okay, 3 times 2, 6, C3H6. Next one. Dust particles dispersed in air is an example of what? To understand the meaning of all these guys here, you first of all need to understand them. Now, what's a colloid? A colloid is when you have like two substances that are of equal volume mixed together. One of them will be like a solute, but it is suspended on the other one. And this colloid, the particles in colloid are very, very tiny. An example of colloid is what you have in milk or fog. So milk does not settle easily. If you keep milk on the table, it will not, the white substances that are suspended on it will not settle. Okay, it will remain pure white like that. Then the next one is emulsion. Emulsion is when you mix two immiscible liquids together. Two liquids that cannot mix. Like when you mix something like oil and water together, you're going to get an emulsion. Okay, so this one is not about dust particles. Next one is suspension. Suspension is kind of similar to dust particles, kind of similar, but it is not it exactly, because in a suspension, the particles will later settle. Like when you put sand inside water, the particles of that sand will later settle down. You will not see the sand at the top. The sand will sink down. But in aerosol is when you have dust particles or tiny particles that are dispersed or suspended in a liquid medium or gaseous medium. The aerosols do not settle. They take a very long time before they can settle. Okay, so the answer to this question, dust particles dispersed in air, is an example of aerosol. Okay, aerosol, that's the answer to that question. Now let's move on. Benzene-like compounds are generally called benzene-like compounds. So basically, in organic chemistry, you have aliphatic compounds and aromatic compounds. Those are the two major classifications. So these alkenes are under aliphatic. Okay, like under aliphatic. So benzenes and benzene-like compounds are generally called aromatic hydrocarbons, so aromatic compounds, because they tend to form close chains like this. So this is benzene, for example. This is the structure of benzene. Okay, and you also have another one called naphthalene. That is if you pair another bond, another benzene molecule by the side like this, you're going to have what is called naphthalene. Okay, keep that in mind. Benzene and benzene-like compounds are called aromatic compounds. Okay, why is aluminium used in making aeroplanes? So it's a very, very unique property. It is lightweight and it is very, very strong. Okay, despite the fact that it has a very small density, it is strong and it can help the aeroplane to fly easily. It can also help the aeroplane to minimize the cost of fuel usage. So you notice that high density is not required, because if the plane is very, very heavy or of a material made of very high density, the plane will not fly easily. Okay, this good conductor of electricity, option C, is not really required. Then shiny and attractive. It's not compulsory for a plane to be shiny and attractive. So it is because aluminium is lightweight, or because of its lightness, that is why it is used in making aeroplanes. So the answer is option A. Okay, next one. Why is type metal used for plumbing? Now, when you're talking about plumbing, you're talking about pipes. And when you're talking about pipes, you're talking about water. So, talking about pipes and water. So these two factors must be considered. Now, why should pipes be of low density? Pipes should not be of low density. Pipes should not be of low density because materials of low density can be easily destroyed. So this property is not actually useful in terms of plumbing. Then ability to dissolve in water. Your pipe or whatever you're using for your plumbing material should not be able to dissolve in water, because in plumbing you're basically dealing with water. So why should your plumbing material be dissolving in water? So this one is of no use. Then resistance to corrosion. Yes, this one is good. This one is very, very proper. Your pipes and other materials should be resistant to corrosion so that they do not rust or decay easily. Okay, so this is a very likely answer. Then high electrical conductivity. This one is not really needed. Why should your pipes be of materials that have very, very high electrical conductivity? It's not as if you're conducting electricity in your toilet or something. So the correct answer is option C. Okay, option C is the answer. Let's go. So next one. Permalloy is an alloy of dash. Permalloy is an alloy of dash. So let's look at this perm here. What should come to your mind is anything that has to do with magnet. Okay, and when you talk about magnets, talking about iron, right? So permalloy is basically an alloy of iron and nickel. Okay, iron and nickel, and it is made up of 80% nickel and 20% of iron. So that is permalloy. Permalloy is basically used in the design of transformers and in other electromagnetic applications like magnetic shielding and so on like that. So permalloy is an alloy of iron and nickel. So that's option C right there. Aluminium is extracted from what? So the answer to this question is a very popular ore. Okay, the popular ore of aluminium, which is made up of different hydrated aluminium compounds, is bauxite. So this is the major ore of aluminium, from which aluminium is extracted by the Bayer process, followed by electrolysis in a process called the Heroult process. Okay, so the answer is bauxite. Hematite is the ore of iron, while cassiterite is the ore of tin. Then cryolite is not actually an ore, is a compound which can be used in the extraction of aluminium. It helps to reduce the temperature. So cryolite is a compound with this formula Na3Al(F6). This is cryolite here, and the name is sodium aluminum fluoride. Okay, so the answer to this question is bauxite. Let's move on. The 6, we have the functional groups in glucose is. Now, glucose is a monosaccharide, that is a carbohydrate or a sugar. So it contains two very important functional groups. This one is glucose contains the functional group RCHO, which is the aldehyde functional group or the alkanal functional group. It also contains another functional group called the alcohol functional group, which is ROH. So if you look at your screen right now, this is the structure of glucose. It contains the functional group RCHO, which is the aldehyde functional group. Glucose is sometimes called an aldose. Okay, so keep that in mind. So the answer is alkanol and alkanal. Alkanal is another name for aldehydes. Okay, so keep that in mind. So the answer is option B. The catalyst used in the contact process is dash. The catalyst used in the contact process is dash. So the answer to this question, first of all, you need to understand what is contact process. Contact process is an industrial process that is used in the manufacture of a gas called SO3. SO3 is sulfur 6 oxide, which is a very important gas because it is the acid anhydride for H2SO4, a very important acid. So the catalyst that is used in this process is vanadium 5 oxide, which has the formula V2O5. Nickel and platinum also used as catalysts in several processes, while iron is majorly used for the ABBA process. That's manufacture of ammonia. If the principal quantum number is 3, the subshell is what? Now, so the principal quantum number is what tells you the energy level where the electron resides. But it also has subshells. The subshells are S, P, D, and F. These are the major subshells. So if the principal quantum number is 3, you're going to have 3S, 3P, and 3D. These are the major subshells in energy level 3. So 3S, 3P, and 3D. No 3F. 3S, 3P, and 3D. Okay, so the answer to that question is option C. The product formed when ammonia is bubbled through ethyl ethanoate is dash. The first thing to note is that your ammonia, that's NH3 plus ethyl ethanoate, which is CH3COOC2H5. So when this reaction takes place, it's going to produce two products. The first product is what is called an amide. An amide. Now, amides have the functional group ROCONH2, which is what you can see here, ROCONH2. That's what they look like. So from this part here, which is CH3, you're going to attach the functional group of amide, which is this one here. So that will give you CH3CONH2. Okay, then lastly, you're going to have what is called ethanol, which is C2H5OH. So this is the product of the reaction. This guy is called an ethanamide. Okay, ethanamide. That is the name of this guy here. But you can also call it acetamide. Now, ethanol is also produced, but if you look at this option here, there's something like ethanol here. They're not showing the second part of the reaction. They're only asking us for the first part. The answer to this question is ethanamide. Be careful of this option, which is ethylamine. Ethylamine is another functional group entirely, that is amines. But this one is amide. So this is the answer here. Okay, now the next one. A sulfide that is soluble in water is dash. So to give us these four options, the first thing to understand is that sulfides contain the sulfide ion, which is S2 minus. And all group 1 elements and all group 2 elements, their sulfides are soluble in water. Okay, keep that in mind. So there are basically 3 sulfides that are insoluble in water. The first one is mercury 2 sulfide, which is HGS. Then you have zinc 2 sulfide, which is ZNS, or zinc sulfide. Then you have tin 2 sulfide, which is SNS. So these 3 guys, they are insoluble in water. And if you notice from this question, you notice that Ca is group 2, magnesium is group 2, and barium is group 2. It's only zinc that is a transition metal there. So zinc is the answer to this question. Now, next one. Mortar is hardened by what? It's hardened by dash. So they give us these 4 options. Now, the first thing, you need to first of all understand what's mortar. Mortar is what is actually used in plastering of houses, filling gaps, and for tiling. Also used in road construction. Now, mortar basically contains cement. It contains water, and it contains sand. So basically, ask yourself, how does cement harden? That's basically what I'm trying to ask you, because cement is one of the major components of mortar. So how does cement harden? How does it become solidified? So for cement to become solidified, there has to be water there, presence of H2O. So when the water is drying up, the cement will be getting harder. So that is by hydration. Okay, cement hardens by hydration. So the same thing here, mortar hardens by hydration. Okay, so next part. 32. The screening effect of inner electrons is one of the factors that affect the magnitude of dash. Okay, so they give us these 4 options here. Electron affinity. This is under periodicity of elements in your chemistry. So they give us these 4 options. So basically, what is screening effect? Screening effect is like, let's assume you have a proton here. Let me not use proton. Let me just say you have a nucleus here, and you have some positive charges inside. Okay, then around this nucleus, you have several levels. And there's an electron on this outermost shell here, an electron here, and these other electrons that are inside these shells here, they are blocking the effect of this proton or this nuclear charge. They are blocking the effect, okay, of this guy on this one, because this one is on the outermost shell. These inner electrons that are on these inner shells, they are blocking it. So that's what is called shielding effect. So because this electron is being shielded, it will be able to move around, and if you just put a little energy, which is the ionization energy, you'll be able to kick off this electron, and this atom will be ionized. So basically, this shielding effect affects the ionization energy more. So is option C. Ionization energy is the energy that has to be given to the element or to the atom for it to lose its outermost electron. So since the shielding effect is very, very high, this electron will be held loosely. So if you put more energy, it will be able to kick off. So atomic size is also a very close answer, but it is not a direct influence. Atomic size is basically due to nuclear charge. Okay, so the answer to this question is option C. Now, bronze is an alloy of dash. To solve this question, you first of all need to understand bronze and brass, because they're kind of confusing if you're not careful. So you have brass and you have bronze. Two of them are alloys. Now, brass is copper plus zinc, while bronze is copper plus tin. Tin is SN, that's the symbol. So don't mix the two up. Bronze is copper plus tin. So that's what they're asking in this question. The alloy of bronze is what? So copper and tin. That's the answer to the question. That's option A. Next question is, what volume of distilled water will be added to 25 cm cube volume of a standard solution to dilute it to 10 times? And these are the options here. The first thing to note is that look for your V1, which is your initial volume. That's V1 is 25 cm cube. So this solution here is already diluted. We want to dilute it to 10 times of the initial volume. So you must first of all find what is called the dilution factor. So dilution factor in this question, which is your DF, it is 10. You can see this is a factor. So that means your final volume, V2, must be equals to 10 times the initial volume. So that means V2 must be equals to DF times V1. So just multiply that. If you multiply that, you're going to get V2 is equals to, that will be 10 times 25. Solve this, you're going to get 250. So 250 cm cube must be the final volume of the solution. But what they're asking you is that what volume of water will you add? Okay, so that this 25 cm cube will become 250. So it's very easy. Just subtract the two answers. Just do 250 cm cube minus 25 cm cube. So anything you get to be your final answer. So the final answer will give you 225 cm cube. So the final answer is option C. If you solve this, you will get 225 cm cube. Okay, so that's the volume of water that you have to add to make the volume to change to 250 cm cube. And for number 35, an isotope has atomic number 18. Okay, what is the mass number of X and Y when X and Y contain 20 and 22 neutrons respectively? So we're looking for the mass number. Atomic number is the number of protons. So mass number, your mass number is equals to sum of protons, okay, or let me say sum of neutrons plus sum of protons. So they are the same thing. Once you add these two, you get the mass number. So check the number of protons that was given in the question. That's 18. Then plus the first one, you have the first one has 20 neutrons. So that will be 20 plus 18. 20 plus 18 will give you 38. That's for the first one, X. Then for Y, which is the second part here, that will be 18 plus 22. That will give you 40. Okay, that will give you 40. So the mass numbers are 38 and 40. So 38 and 40, that's option A. Vulcanizer solution is prepared by dissolving rubber in dash. First of all, you need to understand the process called vulcanization. This is the process in which rubber is strengthened or made to have high durable structure. In this process, you have to heat rubber with sulfur. Okay, rubber is heated with sulfur to make the rubber to be very strong and to have good strength. Okay, to start the process of vulcanization, you must first of all prepare what is called vulcanizer solution. And in that process, you dissolve the rubber, you dissolve it in a solvent, a very strong solvent, which is benzene. Rubber is dissolved in benzene. Okay, petrol or ethanol or kerosene are not strong enough to dissolve rubber. So the strongest one there is benzene, which is an aromatic hydrocarbon. So the answer is benzene, option C. In the table below, which of the following are isomers? So they give us this table here. I want to find which ones are isomers. So first of all, I need to identify the functional groups. ROCHO is a functional group of aldehydes, okay, or alkanals, while ROCOOH is a functional group of carboxylic acids. ROOR prime or ROOR is a functional group of esters, while ROOH is the functional group of what is called alcohols. Now, which of them are isomers? Just remember this chart. Alcohols and ethers, not esters. Ethers is a different functional group entirely. They are isomers. They are functional isomers. They have the same formula, but they have different structures. Okay. Then aldehydes, which is this one, aldehydes and ketones. Ketones is not here. Ketones is the functional group RCO. So ketones and aldehydes, they are functional isomers. Okay. While carboxylic acid and esters are functional isomers. So in this table here, we have carboxylic acids and esters. This is the carboxylic acid here, and this is the ester here. So two of them are functional isomers. So the answer should be U and V. Okay, U and V. So U and V, this is U and this is V. Two of them are functional isomers. So the answer is option B. Okay, next one. To electroplate a teaspoon with nickel, the cathode and anode are what and what respectively? This is under electrolysis. To plate a spoon, you need to use a metal. You put a metal here. You put the spoon on this left hand side. Then you have to have a bath, like a container, which will be the sort of the metal you want to use to electroplate the spoon or the cathode. So the metal that you want to use to cover the spoon or to electroplate the spoon must be the anode. Okay, while the spoon will be the cathode. What you want to cover must be on the negative side. What you are using to cover it must be on the positive side. So that means the positive side must be nickel. Okay, that's the anode. While the cathode, which is negative side, must be where the spun will be. So that when this nickel is depleting or breaking down, it will be moving to the, nickel is a metal. So it will move to the cathode and it will be covering the spun. Then the spun will now look shiny at the end of the electrolysis process. Okay, so take note of that. The anode must be nickel, while the cathode will be the spun, which is what you want to electroplate. So the answer to this question is the cathode. You can see it started cathode first. The cathode must be teaspoon and the anode must be nickel. That is option A. Be careful of option C. Option C is listing the anode part first, the anodic part first, which is not what the question says. The question says cathode first. Okay, so be careful of that. The answer is option A. Which of these is a functional isomer of alkanoates? First of all, what are alkanoates? Alkanoates are basically esters with the functional group ROCOOR prime. Okay, this is the functional group of esters. Now, esters are functional isomers of carboxylic acids. I said it not long ago. Carboxylic acids are also called alkanoic acids. So the answer to this question is option D. Okay, next one is a characteristic of monoclinic sulfur is dash. So monoclinic sulfur is one of the allotropes of sulfur. So you have rhombic sulfur and monoclinic sulfur. So rhombic sulfur is the one that is more like crystalline, more structured, and it has a very, very high melting point. But monoclinic sulfur does not have unique shape. It is jagged somehow. So it has some properties. It is not blue in color, definitely. It does not have a high melting point. The highest one, the one that has a very high melting point, is the rhombic sulfur. And it is not octahedral in shape. Okay, the one that is octahedral is rhombic sulfur. The answer here is a very unique property of monoclinic sulfur, which is that it is bright yellow. It has a very yellow color. So the answer to this question is yellow, or option A. Thank you guys for sticking with me to the end of this video. I really appreciate it. If you are new to Edimat, please click the subscribe button and share this video with your friends so they can participate and enjoy the benefits. Check out the next video on your screen, which will also help you for your JAMB 2025 success.